Helmets on for safety. Welcome back to Random, and today we're going to ask a very kind of cool, kind of weird question for this New Year's Eve, December 31st, 2024. And that question is, where were you December 31st, 2023? Now, you're probably going to say Earth, duh, like many other people. But where exactly was Earth on that day versus where it is today? And that's what we're going to kind of delve into today. When you're in a three-dimensional universe, to move anywhere, you have to move along one of three or more, or one of three axes, or a combination of three axes, okay? So we're talking about X, Y, and Z axis. Now, they're in a configuration a lot like this. Okay, where my index finger is the x-axis or the longitudinal, my middle finger is the y-axis or the lateral, and my thumb is the z-axis. Now, if you say stand in place and jump up and down, you start from calibrated 0 z and go up plus so many inches or so many feet z-axis, and then back down due to gravity. When you move forward, you start from calibrated 0x to plus so many inches or so many feet or so many miles of x. And if you move backwards, you start from calibrated 0 to negative x. And same thing when it comes to the y-axis. Turning left is positive, turning right is negative. So motion in the three-dimensional universe has to happen along those three axes. So when you move up like this, you're moving not only in a plus Z, you're moving in a plus Y, right? So three axes of motion in a three-dimensional universe. When you come to a fourth-dimensional universe, it gets a little more complicated, and my editor is going to have to do quite a bit more research when it comes to that. So where was Earth in 2023, December 31st? Well, it's kind of hard to say. And I say that because we don't necessarily have an outer observation to go on. So you need someone outside of our plane of rotation, outside of the gravitational influence of the sun, basically in a stationary point, to observe the universe as it moves around, because the universe is in motion all around us, right? So let's kind of go delve into this a little bit. All right, so Earth has its orbit around the sun. It's an elliptical orbit, all right? So it's kind of like an egg shape, all right? But it's also helical. So when we're talking about helical, what we mean is it's kind of screws like this, all right? So let's say my middle finger here is the sun. My index finger is Mercury. This finger right here is Venus. My thumb is Earth, and my pinky would be Mars. So it would essentially look like this, right? As you move through space, everything orbits around the sun, and our entire solar system, as it relates to the Milky Way, actually moves around what we call a supermassive black hole in the center of the Milky Way galaxy. Okay, that's basically our position. That's basically how where we are in relation to, say, Alpha Centauri. So we're moving like this around the sun. The sun is moving like this around the galaxy. And of course, the Milky Way galaxy itself is in motion towards the Andromeda galaxy, due for a collision sometime in, I don't know, 1 billion years. It's going to happen, but thankfully not in our lifetime. So as the sun, or as the solar system orbits the sun, like I said, everything is in constant motion. And believe it or not, the sun is actually moving along the z-axis as well. So as it's orbiting the supermassive black hole in the center of the Milky Way galaxy, it's changing direction in the z-axis in either a positive or negative calibrated motion. Okay, so it's either going up or down as it's traveling around the galaxy. So that's kind of cool. So the Earth is what we call, in shorthand, 1 astronomical unit away from the sun. Now that equates to 149.6 million kilometers at its farthest, which, believe it or not, for the northern hemisphere, our summer is when we are farthest away from the sun. The entire planet is farthest away from the sun at that point. And here in winter is when we're actually closest to the sun. So we'll say it's 149.4 kilometers away from the sun. Again, closer. And we're talking astronomical distances, so yes, 149.4 is a lot closer than 149.6. Simple math and arithmetic, blah, blah, blah. All right, so meaning the orbit is not only helical, but is also elliptical. All right, so again, our furthest point away from the sun is summer for the northern hemisphere. Our closest point is winter for the northern hemisphere. It's 149.4. So with the Earth closer to the sun, we experience more, or we are affected more by the sun's gravity, okay? So as we're getting closer and closer to the sun, going from summer to fall into winter, the planet starts accelerating towards the sun because the sun is one of two heaviest objects in the solar system, Jupiter being the second. And believe it or not, the sun and Jupiter actually do pull against one another. See, the sun, it's not static, okay? So so as we're orbiting, the sun is actually doing this, being pulled back and forth by Jupiter and the sun fighting each other with their own gravitational pulls. That's for another video. We'll have to get into that a little deeper a little later. So while the solar system is orbiting the sun, like I said, we're orbiting the supermassive black hole in the center of the Milky Way galaxy. So all this to say, if somehow you had a time machine and you were able to go back to last year, this date, unless your time machine was calibrated to seek a certain gravitational pull, you could end up hundreds or millions of kilometers away from Earth on that day. So let's say this rock right here is Earth today. Earth last year, this same date, is somewhere out there. Now again, we don't know exactly where, and to know exactly where, we would have to have, again, an outside observer to say, hey, you started here and ended up here, or vice versa. At present, we don't know. So that's kind of cool. So when somebody asks, where were you last New Year's Eve, you can say, I was on Earth, but I kind of don't know where Earth was at that time. It's kind of a weird, but also kind of fun answer to that question. So if you learned anything from this video, please like, comment, and subscribe down below. It helps the algorithm. It helps us tell us what we're doing good, what we're doing bad, what we can change, and ultimately what my editor needs to work on, because this clearly isn't working when it comes to editor's notes. He's a lazy bum. Anyway, thank you for joining. I hope you have a happy new year, and many blessings, and good luck to us all in 2025.